In 1992, a cargo ship carrying bath toys got caught in a storm. Shipping containers washed overboard, and the waves swept 28,000 rubber ducks and other toys into the North Pacific. But they didn't stick together. Quite the opposite. The ducks have since washed up all over the world, and researchers have used their paths to chart a better understanding of ocean currents.
The ocean by now has warmed everywhere compared to the late 19th century, except for one very telling exception, this cold blob.
The cold blob is one of the only places on the planet that has actually gotten colder since the Industrial Revolution, and not just a little colder. While our planet's oceans have warmed about 1 degree Celsius, this cold patch in the North Atlantic near Greenland has cooled by nearly the same amount. And if you find this mysterious cold blob a little creepy, you should, because many scientists see it as a sign that a vital Earth system could be nearing collapse with enormous consequences. As more research was conducted, it became clear that the cold blob was not just a brief fluctuation or anomaly. A crucial turning point in understanding the origins of the cold blob occurred when climate models actually predicted its existence. And what had previously seemed like a paradox, a cooling region in an otherwise warming ocean, now appeared in models as a warning signal for one of our planet's most important climate tipping elements.
The climate models show a weakening of what we call the Atlantic Meridional Overturning Circulation, or AMOC for short.
L'emisfero settentrionale deve il suo clima temperato alla corrente nord-atlantica. Il calore del Sole arriva all'equatore ed è trasportato a nord dall'oceano. Ma il surriscaldamento terrestre, che fonde le calotte polari, disturba questo flusso, che alla fine si arresterà. E quando ciò avverrà, tanti saluti al clima temperato.
The Gulf Stream and the Atlantic Meridional Overturning Circulation are two fundamental forces driving the climate and ecosystem dynamics of the North Atlantic, with far-reaching effects on global weather patterns, marine biodiversity, and regional climates, particularly in Europe.
What I'm going to show you here is a small model of the circulation in the entire Atlantic Ocean. So think about that side of the Atlantic is the equator. This side of the North Atlantic is up in the Arctic Ocean. Some ice here for the Arctic. There's a bit of blue food colour in the ice just so that we can see if this works. I've got some red water. And this deep water now, this dense cold water sinking down to the bottom, is clearly creeping along the bottom. You can start to see the return flow of the water in the surface. When it starts to cool, and you'll start to see that red water start to be drawn down into the blue water there as it cools down and becomes dense and starts to sink into the bottom layer. And the blue, that cold water is creeping along the bottom here, and you can see it start to come up at the equator as the warm water is moved and drags that water up from the bottom of the ocean.
The Gulf Stream is a powerful and swift Atlantic Ocean current originating in the Gulf of Mexico, moving up the eastern coast of the United States before curving towards Europe. This warm water current transfers massive amounts of tropical heat northward, playing a significant role in moderating the climates of North America and Western Europe. The Gulf Stream's warm waters deliver mild winter temperatures to much of northwestern Europe, most notably the United Kingdom, Ireland, and parts of Scandinavia, which enjoy a much warmer climate than other regions at similar latitudes. The moisture carried by these currents contributes to regular rainfall, supporting ecosystems and providing the moisture needed for Europe's fertile agricultural lands. Globally, AMOC plays a vital role in mitigating extreme temperature variations. By redistributing heat and regulating the uptake and release of atmospheric carbon, it acts as a balancing force against climate change.
Abbiamo fatto una scoperta straordinaria e preoccupante. Ricorda quello che lei ha detto a Nuova Delhi riguardo alla fusione dei poli che potrebbe fermare la corrente nord-atlantica?
Sì.
Credo stia già avvenendo.
Increased precipitation in the far north and decreased sea ice formation further dilutes the ocean water. This less dense water no longer sinks as readily, which impedes the flow of warm water coming from the south. And today, the AMOC is flowing at its slowest rate in over 1,000 years.
We actually have some paleoclimate evidence of what will happen when the AMOC collapses, because during the last ice age this has happened several times. This will massively change the northern hemisphere temperatures.
The AMOC is currently partly responsible for relatively temperate climates in otherwise far north parts of Europe. If it collapsed,
would have significant cooling in the northern hemisphere, more cooling the more we move northwards. So let's say in Germany it might just be 2 to 3 degrees cooling, but then in northern Norway it may go up to 8 or 10 degrees of cooling. There will be also changes in rainfall patterns. Most alarming consequence will be the southward shift of the tropical rain belt, which will affect the monsoon systems of South America and of Africa. The current West African monsoon region would basically be without monsoon.
Questa è la previsione a 48 ore. E questo è il quadro tra 7-10 giorni. La tempesta finita. Saremo in una nuova era glaciale.
Hundreds of millions of people rely on these monsoons for food production and more, but the impacts don't stop there.
We will see massive impacts on the marine ecosystem, which are very difficult to predict what they exactly will be, but the whole marine ecosystem, the fisheries, all depend strongly on the current situation with the AMOC going.
And another consequence would be seen along the eastern seaboard of North America. And this is where the Gulf Stream comes in.
The sea level on the left-hand side of the Gulf Stream is quite low. On the right-hand side, it's about a meter higher because of the Coriolis force acting on the Gulf Stream and pushing the water to the right, away from the American coast. If you slow down that AMOC and thereby also the Gulf Stream, the water on the left-hand side of the Gulf Stream will go up, leading to a massive extra sea level rise by up to a meter along North Atlantic shores when the AMOC collapses. There are a number of studies that really suggest that the risk is much larger and much closer, actually, with lower levels of warming than we have previously thought.
A new study published in July of 2023 that Dr. Rahmstorf was not a part of warned that we estimate a collapse of the AMOC to occur around mid-century under the current scenario of future emissions.
It doesn't have to completely shut down for us to feel impacts that will be probably quite serious, and we probably already are seeing some of those impacts.
And what's really fascinating and scary is how all of these changes will interact. There's still a lot we don't know.
The combination of natural fluctuations in the climate system that we've seen many times before, like El Nino, La Nina, these cycles that have been happening and evolving over many thousands of years are being disrupted in a very rapid and difficult to predict way. This journey that we're on into uncharted territory is really concerning